The Amino Acid Rapid Imager, or AARI for short, is a system designed around the standardisation of the photography of fingerprints that have been developed on flat, porous evidence types. What we wanted to do was find a solution that simplified and streamlined what has traditionally not been a standard process. So traditionally, what we would do is we would treat our porous evidence with commonly amino acid treatments. So that would be things like Ninhydrin or DFO or 1,2-indundione. Then, after treatment with the appropriate humidity and heat as required for the treatment, the evidence would be examined using alternate light sources if appropriate, marked up, and then each print would be individually photographed on a system. And that would involve focusing the camera and then moving the evidence around beneath the camera to capture each mark. Now this is a really effective process and it will give you very high quality finger marks. However, I'm sure you can imagine that with a high volume of evidence, this can be a very time consuming process. And so what we're actually able to do with AARI is flip this process on its head. So we're able to capture a very high resolution image across a full A4 field of view and then individually mark up these areas post capture, and at the click of a button have all of our images ready to be submitted to our AFIS system. Alongside AARI, we launched our Amino Acid Validation Targets. And these are basically to check that our solutions are functioning as intended. So we have two tests that basically mimic a normal fingerprint or a standard expected fingerprint and a much weaker trace. So hopefully what will happen is when these test strips are treated alongside our evidence is that both tests will develop and then we will know that our solutions are working as intended. These test strips can be integrated in with the AARI workflow. So because they have a barcode on each test strip, we're able to scan this barcode and include both the barcode and an image of the validation sample in the report. So what I'm going to do is I'm just going to talk you through the process of how we can standardize this workflow using both the AARI and our validation samples. So what I'm going to start by doing is capturing an image of the validation sample. So this sample has been treated with indundione alongside our evidence. In order to view indundione, we will use a green light and a 568 bandpass filter. I'm just going to increase the shutter speed slightly and then I'm going to left click on the image to bring it into focus. I'm then going to capture the image of the validation target. And save it into the gallery. Then, simply all I need to do is place my evidence onto the imaging bed, close the lid of the AARI, and again adjust my shutter speed slightly for this sample. Because we have a unique barcode on each validation sample, I'm going to use an external scanner to scan this into the notes section of my sample, so that alongside my image of my evidence, the validation sample I used will be recorded. Then I'm going to come through to the gallery and apply some of the enhancements that are available within the AARI software. I'm going to start by grayscaling this image, and then what I'm going to do is invert the image to give us dark ridges on a light background. Now this piece of evidence is a brown envelope that has been treated with indandine. So it can be quite problematic, but we can see that the use of the bandpass filter has stopped any of that background fluorescence interfering with our evidence. So at this stage, I'm going to mark up some of the regions of interest. Initially, I'm going to do this using the manual markup feature. So this really is as similar as we can get to the standard process that's followed now. So we've captured the image of our full field of view, and then we're marking up the regions of interest as opposed to doing it in the opposite order. However, within the AARI software, we also have our AI assist function. And so what this does is it uses a machine learning algorithm to search our whole image for regions of ridge detail. Initially, these will be displayed as boxes across the image, and so we can see, as there's a lot of finger marks on this particular piece of evidence, there are a lot of boxes that result from our AI. And so I'm just going to group some of these together over my regions of ridge detail that I want to include on the report. So now I am happy with these marked up regions. The next thing I'm going to do is, at the click of a button, save all of these regions to the gallery. So I only have 11 regions marked up on this piece of evidence, but rather than having to photograph all of these regions separately, I've been able to capture one image, and I have all of my 11 regions ready to go if I wanted to export them ready for APHIS submission. What I'm going to do at this stage is crop the image of my validation target slightly smaller so it's a bit more manageable on the report. So to generate a report, which is something that a lot of fingerprint labs have to do for each piece of evidence, all I've done is right-clicked on the image and pressed Generate Report. So we can see that our regions are being displayed on this overview image, and we can add our validation target image so that it can be displayed alongside on the report. So once I press Generate Report, a PDF report will be generated. Within our report, there's some case information, and then we have our validation target image, which shows us that the solution that was used to treat our evidence was working at the time it was treated. Both tests developed successfully. And then we have our overview image and all of our individual regions displayed throughout the report. So really, that's as simple as report generation can be on the AARI, and how seamless the incorporation of the validation targets can be. So if we take a look at a Ninhydrin sample this time, again, I'm going to start by taking an image of my validation sample. So with Ninhydrin, we can simply view this using white light. So I'm going to capture an image again and save that into the gallery. Again, I'm going to place the sample onto the imaging bed and close the lid. And hopefully, what we can start to see is just how simple and straightforward imaging on the AARI is. The AARI has been designed to be appropriate for use for everybody. So whilst something like Ninhydrin, in this case, yes, it might be simple to image it, we have included presets for all of our common porous evidence treatment types. So in the case of Ninhydrin, we have 2 available presets. So what I'm going to do is apply this first preset to just give me a starting point of where I might want to start with my camera settings and my lighting and filter setup. So I'm just going to adjust my camera settings slightly in this case, and then focus on the image. Just right click to use the magnification of the camera sensor to check my focus. Then I'm going to capture an image and save this image into the gallery. So once we open up our evidence, we again have the ability to grayscale. And because these marks are quite high quality, there isn't an enhancement that we need to apply to the whole document. But again, I'm going to start by using the AI Assist to help me to detect any areas of potential ridge detail. And then I'll begin to group these together into the areas that I would like to include on my report. So again, at the press of a button, all of these images are saved into the gallery. And in the case of this image, I'd like to enhance the contrast slightly. So I'm just going to adjust the boundaries on this histogram to slightly change the contrast in this image. And then when I return to the gallery, those enhancements are saved onto our image. So again, we can see that our solution was successful and had been made up successfully. Our treatment cycle was correct because both test 1 and test 2 successfully developed. So the tests that are both mimicking a standard fingerprint and quite a weak trace, both developed. So hopefully that will indicate that our solution was correct and any finger marks that are present on the document will have been developed. Because I applied some enhancements to region 7, I'm now going to replace this region with the enhanced image from the gallery. And then again, add my validation target to show that the target that was treated alongside my evidence is showing that the solutions were correct. And then as I generate my report, there's a notification to say that the image has passed an integrity check, and all that's checking is that the image has not been manipulated outside of the software, which is something that obviously is really important to include on our report because it shows that traceability and integrity of our evidence.